Welcome back to the second video for lesson 4.3. We are starting at example 5. It says Carlos plays college soccer. He makes a goal 65% of the time he shoots. Carlos is going to attempt 2 goals in a row in the next game. A is the event Carlos is successful on his first attempt, and that probability is 0.65. B is the event Carlos is successful on his second attempt, and that probability is 0.65. Carlos tends to shoot in streaks. The probability that he makes a second goal, given that he made the first goal, is 0.9. What is the probability that he makes both goals? Okay, so we know the probability of B given A is 0.90. They told us that right here. And we also know from the lesson earlier in part 1 video that the probability of B given A is equal to the probability of A and B divided by the probability of A. And so if we know the probability of B given A is 0.90, we don't know the probability of A and B. That's what we're trying to find. But we do know that the probability of A is 0.65. So if we multiply both sides by 0.65, that cancels out here on the right, then we will solve for the probability of A and B, which is what we want. And that comes out to be 0.585. The probability that he makes both goals. Okay. What is the probability that Carlos makes either the first goal or the second goal? Okay. So the first or the second means that we have to consider if there's an overlap, meaning he makes both goals, which we did find in part A. So we really want to find the probability of A plus the probability of B, and we're going to subtract that overlap where he makes both goals because we don't want to count that twice. So that would be 0.65 plus 0.65 minus 0.585, which gives us 0.715. And then he said, are events A and B independent? So this is what I'm going to ask myself. If they are independent, what do we know? Then we would know that A and B, the probability of A and B would equal the probability of A times the probability of B, if they are independent, right? So we're going to test this out. So we know the probability of A and B. We found that to be 0.585. And then it's a question mark, right? We're challenging this. So the probability of A is 0.65 times the probability of B, which is 0.65. And that equals 0.4225. So that means that they don't equal. The left does not equal. So that tells us that they are not independent events. That's how you check that. Example 6 on page 92. Example 6 says, suppose a study of speeding violations and drivers who use cell phones produce the following fictional data. We have a table here. It's a two-way table. We have speeding violation in the last year or no speeding violation in the last year. And then on the vertical, we have they use a cell phone while driving or they do not use a cell phone while driving. And it looks like the total of participants was 755. So it says, find the probability that a driver is a cell phone user. So they are a cell phone user while they drive would be 305 out of 755, which is 0.404. B says, what is the probability that a driver had no violation in the last year? So no violation in the last year would be all of these people in this column right here, 685. So that's 0.9073. So find the probability that a driver had no violation in the last year and they were a cell phone user. So no violation in the last year would be here, and they are a cell phone user. So that's just this group because we have to satisfy both of the questions. So 280 out of the 755 is 0.3709. Then D says, find the probability that a driver is a cell phone user or they had no violation in the last year. So because it's an or, we have to look for the overlap. So we're looking at the probability of a cell phone user plus the probability no violation, subtracting the probability of both. So we have 305 people plus 685 people. Subtracting both would be subtracting 280, leaves us with 710 out of 755, which is 0.9404. Letter E says, find the probability that a driver is a cell phone user given the probability had a violation in the last year. Given the driver. So the probability of a cell given they had a violation. So given they had a violation means that we're looking at only the people that had a violation. So that would be out of the 70 people that had a violation. So this one changes our denominator. Now the people that had a violation, the people that use a cell phone, there's only 25 of them. So that's 0.3571. F says, find the probability a driver had no violation last year given the driver was not a cell phone user. So this is the probability of no violation given no cell. So this time, given no cell phone would be the 450 people that do not use a cell phone out of that group. So that's our denominator. There were 405 that also did not have a speeding violation. So given that they don't use a cell phone, they're very likely to not get a speeding violation. So 0.90. Let me finish jotting those down. So example 7 is going to be a little check for you in Canvas. This will be a little assignment for you to complete and just make sure that you have watched the videos and have completed that. So I'm going to let you do this one all on your own. We're looking at 2 questions. One is the height of individuals. Are they tall, medium, or short? And then their weight, whether they're obese, normal, or underweight. And then we're going to answer some questions about those. So go ahead and work that one out and finish the little assignment in Canvas. It'll be called a quiz, but it's just an assignment. And reach out if you have any questions.